Neptune is not what we thought it was. For almost 2 centuries, we have treated it as the last quiet thing in the solar system, a smooth blue marble at the far edge of the dark, so distant that light from the sun takes more than 4 hours to reach it. We told ourselves it was calm, frozen, finished. We were wrong about all 3, because when the James Webb Space Telescope finally turned its golden eye toward this world, the blue planet we grew up with simply vanished. What came back was something paler, stranger, and far more disturbing. A world that is colder than almost anything in the sun's reach, yet somehow still burning from the inside. A world where the wind moves faster than sound, where diamonds fall like rain, and where the largest moon is being slowly torn apart. This is the story of what Webb actually saw at Neptune, and why it should unsettle you. To understand why Neptune is frightening, you have to understand how we found it. Because Neptune is the only planet in history that was discovered with mathematics before anyone ever saw it. In the 1840s, astronomers watching Uranus noticed something impossible. Uranus was not following its orbit. Something out there in the dark was pulling on it. Something massive, invisible, unaccounted for. So a French mathematician named Urbain Le Verrier did something extraordinary. He did not search the sky. He sat down with a pen and calculated where a hidden planet would have to be to explain the pull. He worked out its mass, its distance, its exact position in the sky. Then he mailed the coordinates to an observatory in Berlin. On the very first night they looked, on the 23rd of September, 1846, the astronomers pointed their telescope exactly where the math said to look. And there it was. A planet no human eye had ever seen, sitting almost precisely where a pen and paper had predicted. Think about what that means. We did not stumble onto Neptune. We felt its gravity tugging at another world, traced the disturbance backward, and called it out of the darkness. We summoned it, and for the next 143 years, that distant point of light told us almost nothing about itself. It simply waited, 4 billion kilometers away, for us to come closer. We finally did, once, and only once. In 1989, after 12 years crossing the solar system, a single spacecraft reached Neptune, Voyager 2. It is the only machine humanity has ever sent there, and almost certainly the last one any of us will see in our lifetimes. For a few hours, Voyager swept past the planet at more than 60,000 kilometers an hour, and for the first time, the blue marble became a world. And what it showed us was not the calm we expected. Across the southern hemisphere sat an enormous dark storm, the size of the entire Earth. A hole punched into the atmosphere that scientists named the Great Dark Spot. Around it, white clouds of frozen methane raced across the planet, faster than anything we had ever recorded anywhere in the solar system. The winds at Neptune reach more than 2,000 kilometers an hour. That is faster than the speed of sound. On a planet that receives barely 1/900th of the sunlight Earth gets, something is driving the atmosphere into supersonic fury, and nobody fully understood how. Then Voyager did the only thing it could do. It kept going. It crossed Neptune's orbit, turned toward the edge of the solar system, and left, carrying the last close-up images of this world that anyone would have for over 30 years. After that, Neptune went back to being a smudge, a few pixels, a planet we had touched once and then abandoned to the dark, until Webb. The James Webb Space Telescope does not work the way Voyager did. It never left Earth's neighborhood. It sits about 1.5 million kilometers away, in the cold and the shadow, staring outward. And it does not take photographs the way you and I think of photographs. Webb reads light. It splits the faint glow coming off a distant world into its individual wavelengths and reads the chemistry written into them, which gases, which ices, which temperatures. It does not take a portrait of Neptune. It takes its fingerprints. So when Webb finally pointed its instruments at Neptune in 2022, for the first time in the history of astronomy, we were not just looking at the planet, we were reading it, decoding the light that had traveled 4 hours through the dark to reach us. And the very first thing it told us broke the image we had carried our entire lives. The first shock was the simplest one. Neptune is not blue. Every picture you have ever seen of Neptune, the deep, rich, oceanic blue, is real, visible light. And that color comes from methane gas in its atmosphere, which absorbs red light and scatters back blue. But Webb does not see invisible light. It sees in the infrared. And in the infrared, that same methane does the opposite. It swallows the light almost completely. So when Webb looked at Neptune, the blue planet was gone. In its place hung something that looked like a ghost, a pale, gray-white sphere, dim and faintly glowing, banded with streaks of brighter haze. The friendly blue marble of the textbooks had been a trick of our own eyes the entire time. Strip that away. Look at the planet as it truly radiates, and Neptune becomes something colder and far less familiar. A washed-out world, lit not by the sun it can barely feel, but by the faint chemistry burning in its own clouds. And those bright streaks across it were the second surprise. Neptune has rings. Most people don't know that. They are thin, dark, and so faint that for decades we could barely confirm they existed at all. Voyager caught only ghostly hints of them in 1989, and after that, they essentially disappeared from view. Webb brought them back. In its very first image, Neptune's rings snapped into focus brighter and clearer than they had been in over 30 years. Delicate bands of dust and ice circling a planet that should have been far too quiet to hold onto them. Some of those rings are not smooth at all. They clump into strange arcs, dense knots of material that gravity alone should have smeared out long ago. Something is herding that dust. Something is keeping it in place. And there was one more detail in that image that stopped scientists cold. A bright, glowing band wrapped around Neptune's south pole, a region of the atmosphere mysteriously warmer than everything around it. A hot spot at the bottom of the coldest major planet in the solar system, which raises a question nobody has fully answered. Where is the heat coming from? Let's go back to those winds, because the more closely you look at them, the less sense they make. Out at Neptune, sunlight is feeble. The sun is so far away, it looks like little more than a brilliant star, a pinprick that delivers almost no warmth. On Earth, our weather is a sunlight engine. The heat from the sun stirs our air, drives our storms, moves our oceans. By that logic, Neptune should be still, frozen solid in the dark, dead calm. Instead, it has the most violent weather of any planet we know. Winds tear around the equator at over 2,000 kilometers an hour, supersonic, relentless, faster than the winds of any storm Earth has ever produced or ever will. Webb's instruments tracked bright methane clouds being flung across the planet and watched whole storm systems brighten and shift in a matter of days. Think about what it would mean to stand in that. A wind that fast would not push you. It would erase you. Anything exposed would be stripped away faster than your nerves could send the signal that something was wrong. And there is no shelter, because on Neptune, there is nothing to hide behind. There is no ground at all. Which brings us to what would actually happen to you there. But the winds are not even the strangest thing about Neptune. This is when scientists measured how much heat Neptune gives off and compared it to how much sunlight it receives, the numbers did not add up. Neptune radiates roughly 2.5 times more heat than it gets from the sun. It is leaking energy, pouring it out into space, which means the planet is not simply sitting out there slowly freezing. It is generating heat of its own from somewhere deep inside. We don't fully know why. 4.5 billion years after it formed, Neptune still has a furnace running in its core. Leftover heat from its birth, the slow crush of gravity, friction from material sinking through its depths. Something down there is still hot enough to drive an entire planet's weather from the inside out. That is the engine behind the supersonic winds, not the sun, the planet itself. And here is the part that should unsettle you. Its twin, Uranus, almost the same size, almost the same composition, right next door, does not do this. Uranus is cold and quiet and gives off almost no internal heat at all. Two nearly identical worlds. One is dead, the other is still burning. And we cannot say for certain why. So let's do something the textbooks never let you do. Let's drop you into Neptune and follow you down. The first thing you would notice is that there is no surface to land on. Neptune is not a world you could ever stand on, because there is nothing solid to stand on near the top. It is an ocean of gas that simply gets thicker and thicker the deeper you go, with no line where sky becomes ground. At the cloud tops, the temperature is around -220 degrees Celsius, cold enough that the methane around you freezes into icy haze. The supersonic wind catches you immediately and throws you sideways at the speed of a rifle bullet. You would not fall so much as be flung into the dark. As you sink, the pressure begins to climb. Within minutes, the atmosphere is pressing on you with the weight of an ocean, then many oceans, crushing inward from every direction at once. The gas around you stops behaving like air and starts behaving like liquid, then like something with no name on Earth, a hot, dense, electrically charged fluid, black as ink, screaming with pressure. Keep falling, and it gets hotter, not colder. The deeper you go into Neptune, the closer you get to that hidden furnace. Thousands of kilometers down, the temperature climbs into the thousands of degrees, and the pressure reaches millions of times what you feel right now. And it is down there, in that crushing, superheated dark. Under pressure, no human body could survive for a fraction of a second. That Neptune does the strangest thing of all. It makes diamonds, and it rains them. This is not a metaphor. Deep inside Neptune, the conditions are so extreme that the methane in its atmosphere is ripped apart. Methane is built from carbon and hydrogen, and when you squeeze it under millions of atmospheres of pressure and heat it to thousands of degrees, the bonds break. The carbon is set free, and under that pressure, free carbon does what carbon does. It crystallizes. It forms diamond. Scientists believe that throughout the deep interior of Neptune, carbon is being compressed into solid diamonds, and that these diamonds, heavier than the fluid around them, slowly sink. They drift downward through thousands of kilometers of crushing darkness, falling toward the planet's core, like a slow, glittering rain that has been falling for billions of years and will keep falling long after our sun is dead. Somewhere beneath the calm blue face we grew up with, there may be a hidden layer of diamonds deeper than any ocean, in a place no probe will ever reach. It is beautiful. It is also a quiet reminder that the things we find comforting from a distance are often, up close, completely inhuman. And nothing makes that clearer than Neptune's largest moon. Neptune has a moon named Triton, and Triton should not be there. Almost every large moon in the solar system orbits in the same direction its planet spins. It's a sign that the moon formed alongside the planet, out of the same disk of material. Triton breaks that rule completely. It orbits Neptune backward, the wrong way, against the planet's spin. And that single fact tells us something chilling about its past. Triton did not form at Neptune. It was born somewhere out in the Kuiper Belt, in the frozen graveyard beyond the planets, as a free and independent world. And at some point, billions of years ago, it came too close. Neptune's gravity reached out and seized it. Triton was captured, dragged into orbit around a planet it was never meant to belong to. And when Voyager flew past it in 1989, Triton turned out to be one of the most alien places we have ever seen. Its surface is a frozen shell of nitrogen ice at around -235 degrees, one of the coldest objects ever measured. And yet, even there, Voyager spotted dark plumes erupting from the surface, geysers of nitrogen gas blasting kilometers into the thin sky. A frozen world, still venting from within. But here is Triton's real fate. Its backward orbit is unstable. With every pass, Neptune's gravity drags it a fraction closer. And in the distant future, a few billion years from now, Triton will cross a line and Neptune's tides will tear it apart. The captured moon will be shattered into rubble and spread into a vast, bright ring around the planet that stole it. Neptune is not just holding Triton, it is slowly devouring it. There is one more thing Webb has been watching, and it might be the most unsettling, because it shows that Neptune is not just strange, it is changing right now while we watch. Remember the Great Dark Spot, that Earth-sized storm Voyager photographed in 1989. When the Hubble Space Telescope looked a few years later, it was gone, completely. A storm larger than our entire planet had simply dissolved and vanished. Then new dark spots appeared somewhere else. Then those faded too. Neptune's monstrous storms are not permanent features like Jupiter's Great Red Spot. They are born, they swallow a region the size of a world, and then they die, sometimes in just a few years. Webb is now tracking these vortices in detail we have never had before, watching the planet's face reorganize itself over months. And every time it looks, Neptune is slightly different than it was. New clouds, new bands, new storms rising out of that internal heat and tearing themselves apart. This is not a finished, frozen world. It is a living engine, and it is doing all of this completely alone, in the dark, whether anyone is watching or not. Now widen the view, because here is where Neptune stops being a curiosity and starts being a warning. Neptune is what astronomers call an ice giant. Not a rocky world like Earth, not a gas giant like Jupiter, but something in between. A deep, dense world of water, methane, and ammonia wrapped around a hot core. And for a long time, we assumed ice giants were rare. Oddballs, the leftovers of our solar system. Then we started finding planets around other stars. Thousands of them. And as the count grew, a pattern emerged that nobody expected. The single most common type of planet in our galaxy is not a small, rocky world like ours, and not a giant like Jupiter. It is a world roughly the size of Neptune. Let that settle. The galaxy is full of Neptunes. Billions of them. Worlds with supersonic winds, with furnaces in their cores, with diamond rain falling through crushing dark, with captured moons spiraling toward destruction. The kind of planet we understand the least is also the kind that exists almost everywhere. and we have only ever sent a single spacecraft to the one in our own backyard. For a few hours, more than 30 years ago. Every other thing we know about these worlds, we are reading from light, across distances so vast the numbers stop meaning anything. Webb is right now our only real eye on the most common kind of world in existence. The most ordinary planet in the universe turns out to be one of the most extreme, and we are surrounded by them. We began this story with a pen, with a mathematician who never looked through a telescope, who simply calculated that something massive had to be hiding in the dark, and pointed us to the exact spot where it waited. We summoned Neptune out of the void with nothing but numbers, and for almost 200 years, we believed we understood the thing we had called. We were looking at a painted shell, a calm blue marble that does not actually exist. Underneath it is a world that radiates fire it should not have, that whips its skies into supersonic violence in near-total darkness, that crushes carbon into diamonds and rains them into a core no one will ever see, and that is, even now, tearing its largest moon to pieces in slow motion. The James Webb Space Telescope did not make Neptune frightening. It simply stripped away the comforting color we had painted over it and let us see what was always there, a planet far less finished, far less quiet, and far less safe than the one in our textbooks. Neptune is not the calm edge of the solar system. It is a warning about how little the universe cares for the stories we tell ourselves, and how many worlds exactly like it are waiting out there in the dark, doing the same impossible things, completely unseen. We called one of them out of the shadows once. We are only just beginning to understand what answered. And that's it for this video. Thanks for watching, and I'll see you in the next one.